All right, so this is 10-6, the binomial theorem. When you hear the word bi, what do you think? Two, something about two, right? So binomial, see how this is a binomial because it's a plus b? Okay, we've got mono, we've got tri, we've got bi, so this is a binomial. So before I even do anything, there's a couple of properties that I assume you don't remember if you've ever even seen them. I don't know. So these capital C's stand for combination. It's going to be a button in your calculator that I'll show you later, but for now, let's just write them down. So that says NC0 equals 1, NCN equals 1, NC1 equals N. So just write those down. You don't have to memorize them, but you're going to find out that these problems can be kind of lengthy. So anything you can do to save time, you probably want to do. Okay. So here we go. Let me show you the goal of today, and then I'll show you why all these formulas and stuff are important and helpful. So the goal for today, it says expand each binomial. Expand means what? Make it bigger or smaller? Bigger, right? So to do this, if we didn't know what I'm going to show you now, you would have to write a minus b 6 times, and you would have to FOIL all of them together. That's not fun, right? Not only is it not fun, but it's very easy to make a mistake. So most people are okay with FOIL, like just the two, okay? Some people are okay with 3 of them. But once you get to 4 or more, it's really hard to do. If I had written this out 6 times, I would have to FOIL the first 2, and then FOIL that with the third, and then FOIL that with the fourth. That's a lot of stuff. Does that make sense to you? So it gets pretty messy. So because of that, we have all these other options, all right? So as you get frustrated and say, man, I hate this, I don't want to do it, just remind yourself, well, it's way better than what I was going to have to do, okay? So let's go back up to the top. There's some options here. So if it's, do you see how all these have a coefficient of a 1? You see how that's a 1a and a 1b? Do you see that? So if that happens, I'm going to skip this for right now. This will help us later. The coefficients from a pattern of Pascal's triangle. This is Pascal's triangle, which I don't I don't think you've seen before. See how all these are a 1 all the way down? Do you see that? And then the next one is adding each other. So if you look here, what's 1 plus 1? 2, and you still have the 1s on the side, okay? And then 1 plus 2, 3. 1 plus 2, 3. 3 plus 1, 4. 3 plus 3, 6. 3 plus, do you see how you make the next row? So I could keep going, couldn't I? If I wanted the next row, a plus b to the 6th, this is still a 1, this is still a 1, right? What would this next one be? 6, 15. This would be the 20 here, because the 10 and the 10. The 15 and the 6. Do you guys see that? So it's not like that's like a really hard thing to come up with, right? But when is this going to be an issue? When they're not 1s, right? If this isn't a 1, like on the one on the back, I think it's like 2a plus 5b or something like that, then you can't do that. It doesn't work for those, right? It's just 1s. So this is great, and it's super quick, super easy if they're 1s. If they're not 1s, it's not that helpful, okay? So what I do instead is on your formula sheet, you have this thing. Find that. I think it's like the last thing you have. Do you guys see that? Okay. You know by now that if I can show you something that works for everything, I try to do that instead. So Pascal's triangle is great, and it's super helpful, and it's super quick. But if I have, what number on your notes? Number 19, where it's 2a plus 4b, then I don't have that anymore, okay? So we're going to stick with this today because this works for everything. And plus, the Pascal's triangle, you still have to know this part anyway, because Pascal's triangle doesn't tell you that. You still have to know this pattern that I'm going to show you anyway. So in my opinion, especially for as little as we're going to use these, we're going to use them, but like this is the only chapter kind of a thing. I don't want to get into 50 different ways to do it. I'd rather just pick one that works for everything. I think that's typically better. Is that okay? So if you decide you want to do Pascal's triangle instead, you let me know. But we're going to have to know this one anyway, so we might as well. Okay? I know it looks super scary, but it's not that bad. So with everything else on the front of your notes there, the binomial theorem, just kidding, and factorial, I'm not going to talk about those a ton right now because, again, it kind of answers itself when we do them later. So I'm just going to go here, factorial. This is all stuff that you should have seen in Algebra 1. Not that big, huge formula, okay? You shouldn't have seen that. But you should have seen those C's, the combination and permutation, and factorial. It's okay if you didn't, but those are things we've done before, okay? So factorial, n factorial, it's an exclamation point. In math, the exclamation point means take it times the one below it. So like 4 exclamation point, 4 factorial is 4 times 3 times 2 times 1. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Does that make sense? So because it's not fun to punch into your calculator, there's a factorial button in your calculator. So everybody get your calculator out if it's not already. And we're going to punch in 4 factorial. On most of your calculators, it's the PRB button, which I believe stands for probability. And you have the NCR, and you have the NPR, and you have the factorial button. Do you guys see that on most of your calculators? Okay, so for you guys, go ahead and clear it out. You're going to push the 4 first, then your PRB button, and then the factorial button. On other people, your factorial button is probably on your actual calculator itself. You probably don't have to go to a different screen to find it. So everybody try to find it, okay? And what is 4 factorial? 24. Everybody needs to get 24. Lean to a neighbor or bring your calculator over if you can't find it. Thank you. Is everybody good? Everybody find it? Okay? Obviously you can do it without a calculator, but 4 times 3 times 2 times 1 isn't hard, but if I had given you, I don't know, 50 factorial, you don't want to do that. That would take forever, and you're probably going to mess up, right? So that's all the stuff I want to talk about there. So now we're actually going to do a problem. We're going to do number 15. It says expand. So yes, I can use Pascal's triangle. That's totally fine. But because this is an easy one, I'm going to show you that formula instead, okay? And we'll go back and kind of show you how we could have used Pascal's if you want to. So I'm going to do it right here because I need this formula. You guys, you can obviously do it on number 15. That's fine. So this says a minus b to the 6th. So again, anytime I do something new that looks that confusing, it wouldn't hurt for you maybe just to watch me first and then write it down. I'll say it a few times. I'll go super slowly. But again, if you're someone who just has to write as I write, that's fine too. I don't care. Okay? So we're going to go super slowly. All right? This looks almost just like this. Do you guys get that? Okay? So I don't really want to think of these as A and B. I'm just going to think of it as the first thing and the second thing. Is that okay? Because this could be an X and a Y. This could be 4W and 5T. I don't know what they are. I just know it's the first one and the second one. Is that okay? All right. So this is A plus B to the N, and I have A minus B to the N. All right? So I start with literally, this says NC0. What's N? 6. This is N, right? So I'm going to write 6C0 because that's what this says to do. Is that okay? Okay. It says first thing to the N. So in my problem, what's the first thing? First term, I guess. A. And what did we just say N was? 6. So I just filled in this piece. Then it says second thing. They're calling B the second thing. Second thing to the 0. So on mine, what's the second thing? It's technically negative B. Okay? And that's why I put that in there. To the 0. Because here it's a plus sign, so I didn't have to worry about it. Here it's a negative sign, so that's actually negative B. Do you guys understand that? And that will matter. You'll see why later. Is everybody okay? So if you want to go ahead and write it down now, you can. And I can say it again if you need me to. Okay? So this is A minus B to the N. So NC0 is 6C0. First thing to the N, well, for ours it was A to the 6. Second thing to the 0. For ours, it's negative b to the 0. And you want that negative b to be in parentheses, and I'll show you why later. Okay? So I just did that part. Is that okay? Okay. So I'm just going to copy down my plus sign. It might change later, but again, we'll talk about that later. That says NC1. So what am I going to write? 6C1. Very good. It says first thing to the n minus 1. So first thing for us is a. What did you guys just say n was again? 6. So what's 6 minus 1? 5. It says second thing to the 1. So what's my second thing? Negative b to the 1. I've now done that part. Are you following what I'm doing? Okay. So typically here is where I kind of understand the pattern. Okay. So do you see how it's 6C0, 6C1? What's the next one going to be? 6C2, blah, blah, blah. 6C3, blah, blah, blah. 6C4, 6C5, 6C6. Do you see how I'm going to just go ahead and fill in the pattern? Once I do the first couple, I'm like, oh yeah, here's the pattern. So it was 6C0, 6C1, 6C2, 6C3, 6C4, 6C5, 6C6. I know I'm done when they match. See how it's NCN? And I have 6C6. So I know that that would be the end once I fill in my A's and B's or whatever. Is that okay, what I just did? Okay. So this first part is always a to the something, right? So this was a to the 6. This was a to the 5. This is going to be a to the 4, a to the 3, a to the 2, a to the 1, a to the 0. And I always like to check that I did the last one right. It literally is the first thing to the 0. I have the first thing to the 0. Do you get that pattern? So now it's second thing to the 0, second thing to the 1, second thing to the second. So negative b to the second, negative b to the third, negative b to the 4, negative b to the 5, negative b to the 6th. Ask me a question. All I did was fill in the formula. Is that okay? Did you guys understand the pattern, or should I have done the third one? Are you okay? Okay. So from here, that's not an answer. That doesn't even make sense, right? So from here, we use our calculator, okay? You're going to find out what 6C0 is. So on your calculator, if you had to push the PRB button before, you're going to have to push it again. You're going to do 6PRB0 and get whatever you get. If not, then yours is just on your calculator. Typically, you have to hit second or shift to get it. Okay, so what is 6C0? What'd you get? 1. You should get 1, and I'll wait for you, but everybody get 1, okay? If you can't find it, come over or ask a neighbor. Bless you. Everybody okay with 1? Okay. And then what's a to the 6? It's not a trick question. A to the 6. And what's negative? Well, what's anything to the 0? 1. 1. So I have 1 times a to the 6 times 1. So I get a to the 6. That's done. Is that okay? Okay. So now 6C1, plug that in, and you get 6. What's a to the 5? A to the 5 still. Negative b to the 1 is negative b. So this becomes negative 6a to the 5b. Do you understand that? Did I lose anybody there? Okay. Did I lose you, Farah? Okay. Your eyes looked really wide. Okay. So now we do 6C2. Plug that in. What's 6C2? 15. We still have a to the 4. That's not going to change. What's a negative to an even? Positive, right? So this is positive B2. So I have a positive 15 a to the 4b squared. I'm going to pause and make sure everybody's okay. How do you get what? The C stuff? Okay. If you're good, do this one, please. B squared is B squared. Negative B squared is B squared. Same? Okay. Did you figure it out, Garrett? Are you sure? Okay. Okay, so what's 63? 20. A cubed is still A cubed. That's not going to change. A negative to an odd is a negative. Do you guys get that? So I'm going to get negative 20A cubed B cubed. Is that okay? Try the next piece. Is it going to be a negative or a positive? Positive, because this is a positive, this is a positive, this is a positive. So positive. What do you guys get? 15 a squared b to the 4. Is that okay? Okay. This one's going to be what? Negative or positive? A negative, because positive, positive, a negative to an odd is negative. So I'm going to put one big negative sign there. And what do you get? 6a b to the 5. And then your last term is going to be a positive b to the 6. Take your time, get it right though. They said expand it, we did. That is the answer. You can't combine any of those, none of those are like terms, because we did it without foiling basically. So this formula takes care of the like terms for us. It basically like added them together for us. As unfun as I'm sure that was for you, it was way better than multiplying that out 6 times and combining like terms. Okay? So that is our answer. That's it. It's done. Okay? Now, we could have done Pascal's triangle. So let me show you that, right? This was to the 6th power, and these are both 1s, right? Is that pretty good? Okay, so if we go back to Pascal's triangle, I had a 1, a 6, a 15, a 20. You see what I'm saying? So if I go back to what we added in, 1, 6, 15, 20. Do you see what I'm saying? So if you understand Pascal's triangle and they're both 1s, you kind of can still use this, but we still had to understand the exponents, and we still had to understand which ones were negative and which ones were positive. Do you see what I'm saying? So even Pascal's triangle, you still had to do half of what we did anyway. So if you're going to stick with that, that's fine. But you have to remember that every other one would have been a negative because this was a negative. And then it starts with the first thing to the n, and then those go down, and the second thing goes up. So it's 6, 5, 4, 3, whatever. So it's b to the nothing, b to the 1, b to the 2. Do you see what I'm saying? You still had to know half of what we had to know anyway. So that's why I just stick with the formula. Did you halfway follow me? Okay, we're going to do another one where you're going to feel even better about it. Okay, so when you go ahead and go to the back, we're going to change number 19 because it's almost too easy. Because that's a plus sign. I think the plus signs are easy. I would rather do a minus sign with you. So basically change number 19 completely, okay, to what I have. Make it 5a minus 4b to the 4 instead. And I think that's going to be a better example for us, okay? So we're going to do the same thing we just did. We're going to expand. We're going to use our formula and just change number 19. Okay, so we're still going to expand it. We're going to use that formula on your formula sheet. I prefer for you to use that because that's the one you're always going to have, right? So what's n? 4, right? The exponent is n. Do you guys get that? What's a for me right now? 5a. The first thing, the whole first thing is 5a. What's b? Negative 4b. Do you get that? So we're going to fill in our formula. So the first thing says, I don't have mine right in front of me. What is it? NC0, right? So what am I going to write? 4C0. Is that okay? And then I just kind of skip it. What's the next one? 4C1, and then 4C2, and then 4C3, and then 4C4. And you get that's where you stop, because the last one says NCN. So when the 4 matches the 4, you stop there. I'll fill in the rest in a second, but this is what works best for me. I fill in the first piece, and then I fill in like my A's or whatever, and then I fill in my B's, and then I do the math. That's easier for me pattern-wise. I don't get confused. So again, I look at the formula, and it says, I don't have mine in front of me. Let me see. How does it say it? It says a to the n, b to the 0, right? So I'm going to start with a to the n. So I'm going to say 5a to the what? 4. The next one, I'm skipping the b right now, says a to the n minus 1. Do you see that on your formula sheet? So this is going to be 5a to the 3, 5a to the 2, 5a to the 1, 5a to the 0. Do you see why I'm able to do it so quickly? I figured out the pattern and I just follow it, right? I don't actually look at the formula a million times. I look at it just the once and I'm like, oh yeah, those are going down. So then if you go back, it's going to be the second thing, negative, that's hard to write, 4b to the what in the first spot? 0, negative 4b to the 1, negative 4b to the 2, negative 4b to the 3, and negative 4b to the 4. Take a minute and look this over and make sure you understand how I used the formula and how I got what I got. Because if you can't do this, obviously we might as well just stop. Okay? So look at this again, look at the formula again, and understand how I got that. Ask me a question if I lost you somewhere. So this one, they are not ones, so you can't do the Pascal's thing anyway, right? With this, let me show you one other thing you can do just to check that you're right, bless you. If n is 4, you always want these exponents to add up to n. So what's 4 plus 0? 4. 3 plus 1? 4. 4. 4. That's just another way you could check that you're right. Is that okay? Okay. So we're going to do this together. If you want to find out what 4C0 is in your calculator, that's fine. If you go back to your properties from the front that I had you write down, what's NC0? 1. Every time. So if you want to memorize that, great. It saves you some time. If not, punch it in your calculator. It doesn't matter. So this is a 1, right? What's 5a to the 4? No, it's not 5a to the 4. It's whatever 5 to the 4 is. So 625a to the 4, right? And then what's anything to the 0? A 1. Okay? So 1 times 625a to the 4 times 1 is 625a to the 4, right? So that piece is done. Okay? We also have a property for NC1 if you want to use it. What's NC1? N, so 4C1 is 4, or you can punch it in. It's no big deal. It doesn't take any longer, right? What is 5a to the 3? 125a to the 3, right? And negative 4b to the 1 is negative 4b. Do you see that? So what's 4 times 125 times negative 4? I would punch that in. Negative 2,000 a cubed b. That one's done. Is that okay? I'm going to do one more with you. Okay, what's 4c2? You probably just need to punch that one in. What is it? I don't know. I don't have it. 6, okay. Times, bless you, 5a squared is 25a squared. Negative 4b squared is positive 16b squared. Is that okay? So you're going to take 6 times 25 times 16, and you get 2400 is a positive a squared b squared. Okay? You guys try the next one. Ooh, okay. Anybody think you got it? Excuse me. Let's start off with, is it positive or negative? It's a negative, okay. What's your number? 1280 a b to the third. Is anybody not getting that and need help? If you do, finish it off with that very last one. 4c4 is a property if you want to use it, but if not, that's okay too. You should get plus 256 b to the 4. This is your final answer. Are you okay? Okay. So, let's talk about a couple of patterns that you should notice every single time, okay? In the beginning, the pattern's the same as the end with the variables, so they should add up to, the exponents on the variable should add up to n, 4. So this is 4 because it's b to the 0. That's 4, that's 4, that's 4. Do you see what I'm saying? Okay. Also, it should be a to the 4, a to the third, a to the second, a to the 1, a to the none, and then b to the 0, b to, do you see what I'm saying? That pattern still exists, okay? This one's not a mirror image of itself like the last one. See how it's 1, negative 6, 15, and then the 15, 6, and the 1? You see what I'm saying? The only reason that existed was because those were both 1s. If they're not 1s, then it won't do that. As a rule, anyway. Is that okay? Okay. So that's expansion. We just made it bigger without foiling. Are you okay? Okay. We're not doing that one, like I said. This is the last question. This is why there's only 3 examples, because each question takes 15 minutes. So, last one. It says, find the indicated term of each expression. They want the 5th term of x minus 4 to the 9. Okay? So what that means is, if I were to FOIL that out 9 times, right? Write it out 9 times of FOIL, I'd circle the 5th one. Okay? So if it was this question that they were asking me for, the 5th term, 1, 2, 3, 4, 5, it would be this one. Does that make sense? So you could totally write this down, not do the math. I wouldn't do the math, right? I would be like, okay, 1, 2, 3, 4, 5. Write it down and just do the math on the 5th one. You could do that if you wanted to, right? But it could ask you for the 100th term of something. I don't want to do that, right? So instead, I'm going to show you the formula for finding the whatever term without doing the expansion that we just did. Can you do the expansion if you want to and just circle the 5th term? For sure, that's fine, but it's not as fast, okay? So, back on your formula, you have this. A plus b to the n equals, you have this part, sigma k equals 0 n, n factorial over k factorial, n minus k factorial, a to the n minus k, b to the k. That's what you have. That's the part that we're going to use. They ask you to expand, it's that first part that we did. If they ask you to find the x number of term, it's this part. Again, I know it looks as intimidating as that first part did, but in a second you're going to find out it's just as easy as that first part was. You just need to find out what they want everything to be. Okay? Bless you. Let's start off with, what's n? It's not n as in what we've talked about before. It's here, n. So 9. Do you guys see what I'm saying? N is 9 here. It literally says a plus b to the n. So a, b, n. N is 9. So all those n's, I'm going to put a 9 there. Okay? So I've got a 9 sigma k equals 0 still. I've got a 9 factorial, 9 minus something, something, 9 minus something. Do you see how I just kind of left a bunch of stuff blank? Okay? We also need k. I'll talk to you about that in a second. But I can fill in a and b. That's still the same as before. What's a in this question? It's x, right? So it's going to be x to the something. And then b is negative 4. Do you guys see what I'm saying? None of that is different. Okay? All I did was a, b, and n from before, and I plugged them in. All right. To find k, when you're ready, just watch me, and then I'll teach you something to help you remember it, but I'll show you where it came from first. So remember with sigma, this is, if I plug this in, that's how I get my first term, right? So if I want my fifth term, 1, 2, 3, 4, 5. If I want my fifth one, my first one is when k is 0. My second one is when k is 1. My third one is when k is 2. So what's my fifth one? When k is 0, 1, 2, 3, 4. When k is 4. Okay? So the pattern, if you never want to do that again, is do what? If you want the fifth term, what do? Subtract 1. Yeah. So k is the number of term you want minus 1. I would write that down probably because you're not going to remember that. You can figure it out if you want to, like I did. But again, if they want the 100th term, I don't want to write that many blanks. So whatever you want, if you want the fifth term, k is going to be 4. Okay? So all those k's, I'm going to put 4's in. So this is a 4, this is a 4, this is a 4, and this is a 4. I just filled it in. Okay? I'm going to erase this because I'm going to need space. All right, so again, I know how confusing that looks, but we already knew A from before. We knew B from before. We knew N from before. The only thing that was new was K, and you just subtract 1. Okay? So now we're going to actually do some math. So I do as much math on my own as I can before I use my calculator. Like I'm going to say 9 minus 4 is 5, right? So it's going to be 9 factorial over 4 factorial, 5 factorial, x to the 5, and whatever negative 4 to the 4 is. I'll do that later. Do you guys see what I'm saying? If you had kept it this way, it's not that it's wrong. It's just that you're going to have to really be careful plugging it in, and let's just not play that game with our calculator, okay? So I want everybody to use your calculator to find just this answer, just that piece. I want to see if you can do it without me telling you where to put, like, parentheses and stuff. See what you get for just that piece. Oh, gross. What'd you get? 126 is what you're supposed to get. So if you didn't, let me tell you what probably went wrong, okay? When you divide by more than one thing, a lot of your calculators want parentheses here probably. So I didn't actually need them around the 5, I think, for your calculators, but I did need them around the denominator for a lot of them. So if you did not get 126 the first time, try that. Is anyone not getting it now? Okay. And then x to the 5th is obviously x to the 5th. And then what's negative 4 to the 4? Oh, was there a b on this? No. Okay, I was looking at the other question. Good. Yeah, 256. So then, what do? Multiply them, right? So what do you get? 32,256 x to the 5th. So if I were to do that expansion like I did on all the other questions, my 5th term would be what we just said. The sigma? Nope. Kind of. Yes. Questions? Do you see why we're going to be working on this in class tomorrow with me here to help you immediately? Okay. All right, good. much time do we have? Yeah, 8 minutes. We're not going to do more. I think that's good.